Okay, so we're going to start this lesson with a little bit of review of what we've learned previously. So we're going to solve this equation by factoring. 0 equals x squared minus 2x minus 3. If you remember this type of factoring, it's a trinomial, so it's 3 terms. So what we're going to do is we're going to look for two numbers that multiply to negative 3 and add to negative 2. Because 3 is prime, there's only a couple options. So if we think through this, we want our final result to look like this. Those two numbers would be negative 3 and positive 1, because negative 3 times 1 is negative 3, and negative 3 plus 1 is negative 2. So anyway, to finish this problem out, you have something times something equals 0. So either x minus 3 is 0, or x plus 1 is 0. So x is 3, or x is negative 1. Now the reason we're starting with that is because we're going to look at the same problem, and I'm going to show you today a new way to solve x squared minus 2x minus 3, or any quadratic equation, and that is by actually graphing it. So let's take the exact same function, and now let's graph it. So to graph this, we want to find our axis of symmetry. So x is equal to negative b over 2a, that's our equation. So for us, that would be negative 2 over 2 times 1, which gives us 2 over 2, or 1. So we know our axis of symmetry is right here. And then to round this out, what we're going to want to do is find our vertex and then make a table. So we can find the vertex. To find our y part, we plug 1 in. 1 squared minus 2 times 1 minus 3. Well, 1 squared is 1, minus 2 minus 3 is negative 4. So our vertex is the point 1, negative 4. We can plot that. And then to finish out our graphing, what we're going to want to do is just make a xy table, put that vertex in the middle, and then we can plug in numbers around the vertex. So we can plug in 0, that's an easy number to plug in for x. When we do that, we get negative 3. And then we can reflect that point over at 2. And then we could either plug in negative 1 or 3 to get another point. Let's go ahead and plug in 3. 3 squared, up here 3 squared is 9, minus 2 times 3, so minus 6. So 9 minus 6 minus 3, that's 0. Plot that point, and then we have 0 here, plot that point. And then we can connect these and make our parabola. So how does this help us solve an equation? Well, the equation above was the exact same thing as this, only instead of y, we had a 0. So what we're doing here is we're looking for where on the graph is y equal to 0. Well, that is just the entire x-axis. So what 2 points do we have in which the y value is 0? We have this point and that point. And once you know it, those two values are x equals negative 1 and x equals 3. And those are the exact same results we got from the first step by factoring. So what this means is if you're ever asked to solve an equation where you have 0 equals a bunch of stuff with a quadratic, you can always graph it and then look at the graph. Where is my graph crossing the x-axis? So what this means is if you are ever asked to find the solutions, the roots, the x-intercepts, or when will the whatever hit the ground. So sometimes it's when will the ball hit the ground, or when will the rocket hit the ground. You are always looking for the same thing. You are looking for, hey, what x value do I have when y is 0? So on a graph, that's just where are we crossing the x-axis. So let's try another one. Find the solutions of the following equation by graphing. So we could factor this, but we're asked specifically to do this by graphing. So let's graph it quick. We start with our axis of symmetry, negative b over 2a. So that is negative 4 over 2 times negative 1, which is 4 over negative 2, which is negative 2. We can sketch that out right here. Let's go ahead and find our y part of our vertex. We have negative 2 squared minus 4 times negative 2 plus 5. And we're going to be very careful with all these negatives. So this is negative positive 4 plus 8 plus 5. So this is 9. So our vertex is the point negative 2, 9. And then what we're going to do is we are going to make a table. We're going to plug in points around the vertex. So we have negative 2, 9. So we can plug in negative 1, 0, 1 if we want, negative 3, negative 4, negative 5. Just plug in some points. If we plug in negative 1, we get negative 1 plus 4 plus 5. So that's just 8. We could reflect that over. Let's plug in 0. Plugging in 0 is very straightforward. You get 0 minus 0 plus 5. So we would have 5. We can reflect that. Just for good measure, let's plug in one more point. Let's plug in 1. If we plug in a positive 1, that is 1 squared, and then negative 1, minus 4, minus 5. So it's negative 4, or plus 5, sorry. Negative 1 minus 4 is negative 5, plus 5 is 0. And 0, so we have this point and this point. So if we are solving this by graphing, where are we crossing the x-axis? Well, we're crossing the x-axis here and here. So our solutions are x equals 1 and x equals negative 5. So you'll either see them in the table or you can do it by graphing. And when you get to higher levels of math, you might use a piece of technology if your answer is not a perfect integer answer. You might just be able to look at the x-intercepts using Desmos or some graphing calculator to get there. So our last problem today, we're just going to look at a graph and answer a question. So the graph below models the height of a ball kicked straight into the air. When did the ball hit the ground? Well, this is just graphical interpretation. So what's happening here is we are kicking a ball into the air, and we kick it up, and it goes really, really high. It looks like it goes up 8 feet, and then it comes crashing down. Well, when did it hit the ground? Don't overthink it. When did it hit the ground? It's just where did you cross the x-axis? So we hit the ground at 2 seconds. So to recap kind of our last 2 lessons, if you have a graph like this point is your vertex. This point is your x-intercept. They tell you 2 different things. So the vertex is the highest something gets, or the lowest if it opens up. The x-intercept is where we cross the x-axis. So a lot of times it's answering a question like this one. When did the ball hit the ground? Or when is y equal to 0? It's the same question. All right, that'll wrap it up for this video.